Hi everyone, welcome you all. So previously we have learned how to search an element using a linear search. And today we are going to discuss how to search an element when we have a list in a sorted order. It doesn't matter whether it is in descending or ascending order, but the prerequisite for binary search is the list should be ordered. So let us make a list which is ordered. Let's say it's 20 only. Then we are going to have 25, then 26, then 30, then 89, then 100, then 1000, then okay, 1000, and one more element that is 1500. So this is our list. Okay, now we are going to find an element. That's perfectly fine, and let us get rid of all these. Okay, so now philosophy of our binary search is divide and rule. Okay, now what does that mean? So first of all, we have to calculate the length. Now let us count manually: 1 2 3 4 5 6 7 8 and 9. So we have 9 elements, so we are going to divide it by 2. That's how we can get a mid position. Okay, for example, this is in list. Let me take Excel for this. Okay, you so this is my Excel. Let's have some values. Let me do it like this. Okay, that's perfectly fine. I'm going to have some elements: 10, 12, 13, 15, 16, 17, 20, 25. Okay, it should be 25, 25, 30, 1, 2, 3, 4, 5, 6, 7, 8, 9, and one more. That's 40. Okay, so let's be this. So I'm going to number or index it 0, 1, and up to the 9. That's perfectly fine. So what we are going to do, we are going to first calculate the mid position. That is, mid is equals to uh, mid is equals to what will be the mid. Wait a minute, just a minute, give me a minute. Mid is equals to upper minus lower divided by 2. Okay, what does that mean? That is equals to 0 is the lowest index value and the uppermost index value. So upper minus lower divided by 2. Okay, so here I am getting this. I should not be getting this because I have to calculate it somewhat like this. Okay, now so 4.5, if we have an integer division, that's 4. Okay, so this will be the midpoint. Let us indicate with the sign blue. Okay, now what we are going to do, we are going to compare this value. Let's say if find is equals to LST of mid. Okay, and if we are fortunate enough, then we will find the element at the first time. If we are searching 16, then bingo, that means we found the element. But what if the value is smaller? Let's say the value of find we are searching for is, let's say, 30. Okay, so now you can assume that which part, or you have to analyze which part of my list contains the value. Okay, now analyze. Now you can easily analyze this, or you can get to the conclusion that find may be present in the left hand side of the mid position, not toward the right. Now why? Because 13 is less than 16 and list is sorted in ascending order. That mean probability of finding 13 is in the left hand side rather in the right hand side. Okay, so we have to search here. Okay, let us indicate now. Our search area will shrink to the left hand side of the list. We are going to analyze this situation again. Let us calculate the mid again, and the mid is the maximum value, that is 3. So from 9 we are reducing it to mid minus 1. That is the new upper bound for the list, because we have to search this much only. So this is our upper bound, and minus 0 divided by 2. And let's calculate properly. Now it is 1.5, and if we do it, it's an integer division, and the next midpoint we will get is 12. And now we are going to calculate this again, and you will find that this condition is false. Okay, now if the condition is false, that means we are not able to find it. Now again we have to search for a probability which part of the list may contain our find. Now in this scenario, since 12 is less than the find, so probability of finding our find variable, or 13, is toward the right hand side of the list, or in these two elements. And most probably, and if the list is sorted properly, there is no chance that you can find any element that is 13 toward the right hand side. Okay, so now what we are going to do, we are going to calculate this again. Mid is equals to, what is mid? Mid is equals to upper bound, that is 3, minus lower bound, that is 2, divided by 2. Okay, we are getting how much? You can see 0.5. Okay, wait a minute, it should be plus, I think. Okay, we are getting 2.5, and if we simply, okay, pardon me, it should be plus. Okay, wait a minute, it should be plus only. The calculation was not affected since we have taken lower bound as 0, but if it should be per plus. Apologies. Okay, so 2.5, and if we take an integer division, that is 2. Okay, now the third time we will be getting mid position is equals to 13, and if we calculate or perform this value, this equation, bingo, we found our match, and we can say we found the element. And if it is not, we have to repeat the cycle again. Now here one thing is noticed, one thing you should notice is, whenever we have a midpoint and we are not finding the element, we have to search whether it should be present in the left hand side and right hand side. If the value is smaller, then it is present toward the right hand side, and the value for the upper is mid minus 1. And if it is toward the right hand side, it should be mid plus 1. We have to take care of it. Okay, and this process is repeated till your upper bound is greater than the lower bound. Okay, so let's do it. Okay, so now what we are going to do, we are going to take a lower bound is equals to 0, and upper bound u is equals to len of list minus 1. Okay, and that's perfectly fine, while we are saying L is smaller than equals to U. This is the first requirement. We are going to repeat till lower bound is greater than the upper bound. Okay, now first thing first, we have to calculate the mid position. Mid is equals to that's upper bound plus lower bound divided by 2. Okay, now if this list of, okay, LST of mid is equals to the value of find, then we can say print found at let's say mid. Okay, and let's break. That's perfectly fine. What if the LST of, or we can say find, is less than the LST of mid? That means the value is present toward the left hand side. That means your upper bound should decreased to 1 minus the mid value. Okay, and otherwise your lower value should be 1 plus the mid. Okay, now let's, I think this program is complete, and we can initialize the value, another value called found is equals to false, and if it is true, if we are able to find it, so let's say found is equals to true, so that we can conclude that the value is present or not. If found is equals to false, then we can say print value not found, value is not present. Okay, now let us run and test this value. Now I will be searching, let's say 30. Okay, I'm getting mid is not defined. Okay, it should be equals to, right? Sorry, 30. Let's run this program and equals to found where. Okay, it is found, right? Now let us execute this program and check it out. 30 and found at 4. Okay, so this is working. And what if I say 1000? Still I'm able to find it. And what if it is 1500? Let's run this program again and check it out. Okay, it was 1500. Okay, found at it. Now for the first element, that is 7, let us run this program and check it out whether we are able to find it or not. So found at 0. Perfect, right? Now let us debug this program and check it out how it is actually working, so that we can understand it better, right? So run, and I'm going to debug this program, and let's say searching, perfectly fine. Okay, and in the console it is taking a little while. Enter any number, let's say this time it is 25. That's perfectly fine. So 25, hit enter. Okay, now you can check out various values. I is equals to 0, u is equals to 8, that is number of element minus the 1. Okay, and this is your list. Found is equals to false, find is equals to 25. So we are searching for find, that is 25. Okay, hope you got it. Now if you press F8, it will go one step ahead since the condition is true. Now mid is equals to u plus 1, that is u is equals to 0, 0 plus 8 is equals to 8 divided by 2 is equals to 4. So if you see mid is equals to 4, that's perfectly fine. And if we check out mid of a list mid, that is 4, 0, 1, 2, 3, 4. So it should be 30. 30 is not equals to the value which we are searching for, that is 25. So the condition will fail. And since find the value of find is 25, so probability is that we are able to find out toward the left hand side. So u upper bound should be shifted to mid minus 1. So this time upper bound from 8 has updated to 4, right? So we will be searching only this part of the rest, and rest is ignored, or you can say that we are not going to search that part. Now next, again mid is calculated. Now you can see mid is now 1, so we are here, and 25 is not present at this place, so obviously condition false, and this condition is also false. So now this time L is increased, or lower bound is increased from 0 to 2. Okay, because the value of a mid was 1. Now again midpoint is calculated, and this time 2 is the midpoint, condition is true, so found at 25, and finally found is equals to true, break, condition false, and so you get the output found at 2. Okay, now so this is how we can do it. Now let us try to enter an element that is not present in the list. Okay, just enter, value is not present, bingo. So actually this is pretty faster, or faster than your normal linear search. Now you can imagine a situation where we have thousands of elements. Linear search will divide it and further divide it, so obviously it will take less iterations, while linear search will have to have 1000 iterations if it is a worst case scenario. That means the value is present at the end, then it will completely take how many iterations? 1,000 iterations. That's why binary search is used. Okay, that's all for today. Hope you liked it. Bye bye. See you next time.